I will move forward with the data interpretation and web application. For this, I'll be talking about the web tool, the web application to get the flow duration classes through three steps. First step. As Brian mentioned earlier, you'll need the web application to interpret the data to arrive at one of four classifications for the assessed reach. In addition to the three classes, there is the at least intermittent or not ephemeral class. The web application is our Shiny app that you'll be able to access through this link that's shown on the top here. The first tab provides a brief overview of the beta S dams, the Northeast and Southeast S dams. The second tab is where you'll be able to enter data and run the model to compute the assessed reach classification, as well as download a report of the data that you entered with its final classification. The third tab will include useful links, online resources for users. Before I get to the web application, I wanted to go over that fourth class, what it means and why we have it. So remember that because we wanted to have high confidence in our model predictions for classes, we set the beta S dams to assign ephemeral, intermittent, or perennial classes only when at least 50% of the votes from the random forest models predicted a class. And if that condition was not met, but a combination of intermittent and perennial votes was at least 50%, then the reach was assigned at least intermittent. So at least intermittent means that the observed indicators do not reflect a reach having ephemeral flow, but they are insufficiently clear to eliminate the reach from being either perennial or intermittent. Keep in mind too that the at least intermittent classification does not necessarily mean that all the indicators scored at a level reflecting a flow duration that is almost perennial. In fact, in many of the cases, at least intermittent results occurred because the model had some votes for ephemeral. Typically 30 to 40% of the votes across all the decision trees in the random forest had a vote of ephemeral for a reach when it has at least intermittent. But the combination of intermittent and perennial are more than 50%. This classification may still be sufficient for most decisions, maybe not all. But we observed that this classification occurred fairly rarely in the training and uncommonly also in the testing data sets. So additional information like a well-timed observation may provide enough confidence for a more definitive classification, such as going out in the peak of summer to see if the stream is flowing when you're not in a drought situation. If you have an at least intermittent class from a wet season visit. You're gonna start using the application here. Start by identifying the reach location by either entering the site coordinates that you collected while in the field as decimal degrees into the web application. This will let you know which region the site is in and which set of indicators to enter. The exact coordinates aren't needed for you to determine the correct region, but they are needed to calculate the precipitation metrics appropriately, because that is done automatically through a raster data set that is associated with our SDAM regions. So we need to have that. That's a 800 meter resolution. So in some places, it could vary quite a bit. If you are near a ridge top or a mountain area, it may vary quite a bit. So you do want to get that as close as possible. And like we mentioned earlier, near confluences and things, that will affect also the drainage area metric that you're going to get at through StreamStats or the national map application. Another way to identify the reach location is by using the map option. So that drop down has an option to enter coordinates directly in decimal degrees, or to open up a map that you can zoom in. There are two different layers that you can view, the Nat Geo as well as aerial imagery. So if you do have a good sense of where you are, and a reach where it's located, because you have a lot of notes taken from the field and it's visible, you could probably use that. I would probably lean you towards trying to get accurate coordinates instead while in the field. One reason is a lot of channels aren't going to be shown on these two layers or visible, so you'd probably want to rely on your field collected coordinates instead. The application will tell you if you've entered coordinates that are outside the northeast or southeast region, and then that you would need to run a separate SDAM model. So it will provide a link. For instance, if you give coordinates that are in the Western Mountains, it'll provide you with the link to the Western Mountains SDAM tool. Keep in mind too, when you're dealing with decimal degrees, you want to use a negative for your longitude, so that way will be in the correct region. So for the Northeast, you're going to start by entering the BMI score metrics that Amy went over. You want to select the score for upland rooted plants in the stream bed, and then select the number of densitometer readings taken, and then enter the values that you have for the densitometer readings. The average percent shade using the web tool is dynamically calculated, so you can see it change as you enter your values. If an option to do too is if you already have calculated the average densitometer value, is you could select one and then for the one reading and then enter the average value. It's just in the report, it won't show the discrete individual values. So it sort of depends on how you want to show the data, the rawest form or the value used to calculate the metric. Next slide are the shorter version of the or the more extended version of the Southeast model. You have the BMI vetmetric scores that you'll enter. You won't have to enter in a separate value for the total macroinvertebrate score. That'll be automatically calculated from the value that you enter in for that. Upland plants in the stream bed, enter that as well. For both SDAM regions, you'll enter the drainage area to the nearest 1/10 of a mile. And then the web tool will automatically identify the appropriate bin classes for those. And like I said earlier, the total 30-year average precipitation for the respective regions, seasons, those will be automatically retrieved from the raster and brought into the random forest model to derive a classification. The next are the geomorphic indicators. For the Northeast, you'll select the scores for natural valley indicator and enter the individual bankful width measurements. Like the shade or the densitometer readings, the average will be calculated dynamically. And like the shade, you can just enter the average bankful width by just selecting one measurement and enter that value for the average. But if you'd like the raw values to be included in the report, you can enter those as well. For the southeast, it's similar, but you instead of having natural value, you've got the particle size substrate scoring metric. You select the appropriate value for that and then enter in the bank full widths. And then once you've got all your metric values entered into the web tool application, you select run model, and then the application will provide the assessment reach classification based on the indicator or the metric data that you've entered. You can mark the class on your field form at this point, or and then stop there, or you can fill out some additional information to have a report made. And that's what's the next slide. So if you'd like a standardized report, you fill out the site and supplemental information from your field forms. You can upload photos associated with any of the different metrics, as well as images to characterize flow in the reach. You can enter descriptions, observations you've made in various notes. You can upload, if you've done a field sketch, you can take a picture of that, upload that into the online report that you generate, or the web tool report that you'll generate. It will produce a PDF that you can then save on your local computer. No data is stored or shared with EPA or the Corps or their contractors when you use the app. So it's only can be stored locally on your computer as a PDF. Here's an example. This is from the Great Plains, but it'll be identical for the Northeast. Here's an example printout of a report that includes site information, how photos will look, the indicator collected, and then the last line will be what the assessment reach classification was. This will also be where you'll be able to visualize or see what the average precipitation metrics were calculated from the PRISM data set. So there are cases where additional information is desired. When an assessment was done in poor conditions, you can consider some options for getting additional information. Assessing the reach at a later time might be an option when the site was affected by a transient disturbance that affects your ability to measure indicators. This might be done in a matter of a few weeks, like we talked about earlier, or it could be dependent on season. If you're in a heavy snowfall time, you may want to come back when you can see and identify any plants that might be growing in the stream bed. Observing flow conditions during the opposite season, wet season or dry season, can also be useful.